This conference will now be recorded. This conference will now be recorded.
Connected online, you're able to see the screen?
Yes,
Anyone
we
confirm?
can see this. Yeah, we can see yes.
Okay. Okay, so we can start. Let's keep this session interactive because if we and don't feel shy or no question is stupid. We all are about asking questions because that's what will help you understand the things. Okay. So I'll start with mine. I'm Vinay. I have around 12 years of experience in building low latency, high volume, scalable applications. Like I have worked on payment gateways, getting applications, and predominantly I've been working on Java. On the latest Java tech stack. Nowadays I'm also exploring Python. Sorry. Guys, can you put your system on mute for now? You can unmute when you have a question or any clarification. Thanks. Yeah, so nowadays I'm exploring Python. I like to explore new technologies. I'm also reading about blockchain. I like to attend hackathons. So I'm kind of a tech enthusiast and I like to attend trainings as well. I mean, give trainings as well. That's about the introduction. So I'll give you high level agenda. I'm going to ask you a problem. So how that journey, we will take it, like how do we handle that question? How do we go about it from like so let's start the problem. So let's take one problem, design YouTube. So it's like a common application it's a common design interview question that okay, you have an application like YouTube which can serve multiple videos. Ask you assume you're sitting in an interview. Okay. Yes, so this. Maintain login. Anything else? Yeah, anyone else? Anything else? I mean, sorry. You're sitting in an interview, someone asks anything. First, response to this design. Some way to store videos. We need some sort of programming language as well. But to start with, I think first question should be, what are the
Load
exact
balancer.
requirements? You can't design load balancer yet. Balancer thing. So I think first thing that kind of missed is the requirement. I know you think that you understand YouTube is fine, but when you are sitting in an interview, is kind of a couple of hour interview. You have 2 hours. You obviously cannot design the complete YouTube application. Interviewer maybe is not looking for you to have everything that you do. So you need to understand what is the exact to get. That's the foremost important thing. Then this definition. As I mentioned, the complete system. I mean, there is a full team of engineers working, in creating YouTube. In 2 hours, you can't start something from scratch and come up with the complete design. So scope means there are multiple things to do, and then you can focus your energy towards that part of the problem instead of like you need to have multiple things. You need logging, you need security, you need this, you need that. Then it's kind of you get into a that has been asked. Third is once you understand the high level scope, instead of going to the detail of let's say technology or anything, because some people will jump in that okay, I use Hadoop for this, I use this DB. You need to get uh, thanks. I think there was some disturbance. Yeah. You just create some rectangles. You specify core systems. Those core components will interact with. That's your first step. Diagram. Then you can focus on and processor, all these needs. We'll cover this in detail when we go to our actual course in system design concepts. We'll see that how to get this. It's like cover it in course. We can resume the video. Yeah, we have recommendations. You can create your channel. If you are sending message in chat, I'm not able to see chat unfortunately. So if you can just unmute and give us suggestions as well. So what all features you think we have in YouTube? Or is there a multiple features? Most important feature we are missing there?
Yeah, user profile management system.
As well. Any other feature? Comments as well. So yeah. Like many features. And if I ask you to develop all this, Otherwise, you just can't do anything to us. So these are function features that a user will come and he'll do these things. Some are non-function requirements as well of a system. So non-functional basically, and there is too much lag. Will you go to that application? No, right? Got lost. Not there. The system is not reliable.
Availability, like how much the time, what should be the availability of the system? Should it be like, what should be the latency?
Video applications, there's too much lag. No one is going to come to your application. So if you say feature-wise, maybe there will. Yeah, sorry, go on. Yeah. So there will be obviously no API for, you say that this API is for high availability, this API is for reliability. So that's why we call these are non-functional requirements. But even these you need to, take care of in your design. Like I think when you start with the basic design, maybe you will not care about that. But as you progress, you keep on enhancing your design. You'll have to think of these non-functional requirements as well. So it's good to understand from the interviewer what exactly he wants. Like all these things should be taken care of, or we can ignore them. So yeah. You can't do everything, so you focus on some particular thing. So today, let's say we are just focusing on two things: view a video and upload a video. So I asked you to create the video and play it back. So what do you think? That system will look like? Very.
So from there we have to go to some location.
Yeah. So yeah, correct. Anything else? Anyone thinks that we should have? So you have a system in which you upload something that gets saved, you retrieve it back.
Some key also should be associated with the story.
Yeah. To find it back. So moving back. So this is what a typical web application or any application will look like. You have a client, web application. Right now, we HTML static page, anything, HTML5 application, any web application we're talking about, we're not getting into detail. Then obviously this web application needs to talk over here that will take care of all the requests and response. And now worrying about what kind of database it is. Is it like MS SQL? Is it Oracle? Level, we don't worry about that. We are just simply saying this is my application that looks like. So now let's say we have created this block diagram. Load start to increase. Lot many users started accessing my application. So let's say I started the application on my laptop as a server. I'm using my laptop as a server. I made this live. Now there are too many users. There is some sort of load is. What do you think will happen?
Yes,
Server cannot handle it.
so we need multiple instances. So the load balance.
Yeah. So we need multiple instances. Anything else? So the server. So then it becomes 100, thousands. Every request, when we get a new request, we get it. So obviously your system, you can have limited number of users that can be handled on that machine. In there. So what do you need? You have multiple machines, connect them together so that load is kind of shared. Works. So either vertical scaling, obviously it will work only to an extent. Multiple servers. So now let's say I have my application with servers, I have a webcam connected to these servers, and that is connected to DB. Any issue you see here?
That will take care of the load balancing. So we need load balancing.
Client, the DNS concept. So you have an IP, that IP gets mapped to a domain name, DNS. So now if we have multiple servers, how would a DNS decide that, okay, which request should I send to which server? Which IP is, so let's say my site is google.com, this google.com maps to which IP? It's not clear. So that's where we have to get a load balancer in picture. So this load balancer will take all the requests and then it will distribute it across different servers. Like round robin based on the business of the server, all these things. And then there is a problem of session management. So first, we basically say HTTP is a stateless protocol. Any idea what does it mean? Why we call HTTP?
So HTTP stateless protocol, so there is no proper session for that.
Yeah.
So it will every time. So we don't need to something like.
Even
don't store from where it's coming. The request and the response.
but when you send a request, you get a response back, right? Login, you get a response back that either you are now logged in or you are, incorrect username and password. You get a response back.
So basically, that information will be available in the client side or in the cookie side browsers, right? So basically, server side will not maintain any same.
Yeah. Response back. Subsequent request has no knowledge of what was the prior request. So that's why there is no state maintained. One time request, one time response, no further storage of that. But what kind of problem these things can have? Let's say you go to Amazon, you like one product, you add it to your basket. Request one, add product one to basket, add it to basket, response back. Now you select second product. You again say second product. Server doesn't have that product. It will remove that product. It will show you. You just have product, which is product two. But when you go to Amazon, do you see this happening? No. Why?
So they will maintain the data in the database. So every time, so the request comes back. So if we are trying to add, so even not only if suppose if I log in from one mission, so if I try to add that data, they will not store in that session. They will store it. So
Basically, that's called session management. So now server. So let's say your request goes to server 1, maintains the session. Subsequent request goes to server 2. Any idea about what was stored in server 1 session? There is a problem. So there are ways to handle these things. Either we create a separate session management service, or there is a concept of sticky session as well, which gets complicated. We can use that as well. So there are different techniques. We'll be covering it in much more detail. But yeah, so we need to understand that once we add multiple servers, so now let's say you are uploading a video, upload is done. You're not uploading a duplicate video. You should not be uploading any prohibited content. They need to encode the videos into different format. So let's say from mobile. So these all things will take some time. I mean, checking a prohibiting content, they have to apply some algorithm on that video, and this will take time. So let's say now you as a user going on YouTube, uploading a video. Upload took, let's say you have a very high act 500, so you uploaded it in 2 minutes. Now YouTube is saying, I'm processing it, I'm doing this, I'm doing check this, that. For YouTube to do all this processing. So you would like to wait for those 15 minutes. You will not. So what to do? So what is asynchronism?
So once the upload is done, so we have to give back the acknowledge to them. So we have to acknowledge them. So after that, we have to start the processing in backend.
Okay. Anyone else who's online? So do you understand the problem? So basically now we but there's some processing time that needs, let's say 15 minutes. You don't want user to wait for those 15 minutes for that video to be uploaded. What will you do? Okay. So as he suggested, we need to use some sort of asynchronism. So asynchronous basically means you send a request, synchronous send an acknowledgement. I am working on it. This is your token. In future, if you want to check if the request is complete or not, just send me this token, unique token per request, and I'll tell you if it is complete or not. Or there is something called push-based system where server sends a notification using, let's say, WebSocket or conference. Server sends a response that okay, this is so what should we do? So at the server end, we will have a process queue. So server will get the request, dump it in the queue, send the response to client that okay, I have got your video. Once it is uploaded, I'll let you know. Or once it is published, I'll let you know. System. Instead of waiting for 30 minutes, you will just get an acknowledgement. And after, let's say 15 minutes, YouTube can send an email to you, your video got published, or your video had these issues because of which it couldn't be published. You don't have to wait for that. You're not wasting your 15 minutes for getting a response back. So this is something called asynchronism. Now, how to handle this processing queues and all, we'll cover it in detail in the course. So that's the concept of processing queue. Our time I improved by asynchronism, processing queue, and multiple users can now upload the video. If someone is viewing my video, they are complaining that there is a lag. What do you think, in the system, what is still the issue? People are still complaining that upload is really good, but when I view a video, I see a lag. Architecture as of now. So I have a client connected to a web application. That web application connects to load balancer. The loads balance equally among some that okay, this is a system, improve it. So first we have to identify what do you think is the problem. That can the quality is fine. Lag in viewing a video. As we have more and more users, there's more and more lag in watching videos. Anyone online wants to see this is the problem?
Only one device.
Yeah, what's the problem?
While we are receiving the data from UI, so it will come as a stream.
But how will it, create problem with lag? So I think he's correct. One database, that's the problem.
All
Yeah. So guys, sorry if you are sending messages session, you can just unmute and tell us. Yeah. So basically we are saying we are scaling our application. YouTube, hundreds, thousands, lakhs of users access YouTube. Database has some limitations. You can connect, let's say 100,000, few thousand connections to a database simultaneously. If you keep on adding more and more connections, performance will go. Database is becoming slow. So what can we do here?
We need multiple instances for database transfer. Data replication.
So we need anything else? And when we say multiple databases, what exactly, how will we handle multiple databases?
Suddenly update multiple data.
Yeah, update will also be a problem.
In the session, so while after getting the data from database, right? So we have to keep it session. So all the requests should have to take from the session. So in any case, that session should be always up to date.
Yeah, session.
Before updating in database, so we have to update in cache first.
Yeah, there's a concept of cache as well. So let's see how we can improve that. So one is having multiple databases. Since YouTube
YouTube
is a video in YouTube.
YouTube to sign na Tulamin Karen.
Anyone?
So the Kona Kerala
YouTube?
Sangra. Keep Kona Karen. Asti video tavan videos on database use screen the video for store kiri thavane. Papa extra open rhymes video papa. Ite sangra da. The sangra da YouTube ri sangra da. Daily extra video pakra. Vatikaran sir.
No, I'm just. Guys, are you still having problem hearing the video? Sorry, hearing the lecture? Some people mentioned that they are feeling some lag. Hello?
Yeah, right now it's okay.
Okay, good.
Yeah.
Yeah. So one is you can have multiple. So yeah, as I was saying, maybe one user is writing, others are reading. So we are saying we will have one master. Everyone will write to that. you have to retrieve video, slave 1, slave 2, slave 3. Because if you are read heavy, you can usually get better with that. Then you need a master application. So let's say there is some other application in which you write as well, let's say Facebook, where you have user posting comments as well, reading comments as well. So there you need master application. We'll cover it in detail in course. DB sharding. So basically we are saying we just partition our databases. Video, let's say I say that. Yeah.
So again,
videos related to, let's say,
again voice lag is coming. Again voice started breaking.
Brother.
Bye. We don't have that character actually.
Again voice is breaking.
Okay. Is it fine now?
Yeah.
Okay. Let us know if it is further lag. So interesting other thing would be DB sharding. So that means you can store videos based on, let's say I say that all the videos starting from A to E will be in one database. F from M will be in one database, all other videos in one database. So now basically we are saying we load in the database itself. Like some videos in database 2, so that you get parallelism. So if some users are coming for videos, let's say A to E, they will go to database 1, other will go to database 2, so get your balancing view. That's one more technique you can use. Third is, we have to see if SQL is the right choice, or should we go with some NoSQL database, or we should go, let's say, so again we will cover it in the course in detail, like what kind of database is best suitable for a given problem. Everywhere NoSQL will not work, everywhere SQL will not work. So we'll understand like what's the best database to use. And then obviously cache. If you add a cache, you'll caching in place, and you go to that cache, you get the video.
And
another problem here is
one more thing. So
popular videos.
We are going to store the videos in the. We are going to store the videos into the database or on the file system.
That's what I'm saying. That's the decision we have to take. So if you put it in database and you see there is lag, then maybe SPFS or any system will be a better choice. So how to decide what's best to use and why to use this, we will be covering in more detail in our course.
No, actually my question is that okay. I mean, how we know that okay, database will be fast or the file system will be fast?
So you can run some checks. First of all, let's say you use some tool like JMeter, you run some checks on the system, you simulate a load of 200 users as one way, and other.
But theoretically, can't we define that okay, file system will be good or the database will be good?
So since you need, so basically if you put something in database, video will be kind of a blob sort of structure, which is like too heavy. So obviously if you put it in database, it will be not that fast. Then obviously in real life use cases, specific databases or file system which are optimized for video. So if you have simple text, integers, getting it into database, storing and retrieving is really fast. But if you say about video, which is a blob sort of object, let's say you have 1 GB of data, obviously storing it in a RDBMS kind of structure will make it slow. So that's why you have to, better would be a file system sort of place. So that's how you can decide that you want to use RDBMS or NoSQL.
YouTube is using the file system for storing the videos.
Sorry?
So YouTube is using the file system for storing their videos.
Yeah.
This is this was my question. I was just asking.
I'll have to check like what exactly YouTube is using. Most likely they're using a distributed file system only, because that's the, so they are using not even one database, they're using multiple databases. So let's say you have this metadata related to videos, let's say their thumbnails, number of like, comments, they will be using one database for that. For storing videos, they'll be using a file system, and then for creating user profile, they will be again using a SQL or kind of a MongoDB sort of document
Right.
structure. So multiple kinds of databases, not just one database. One database cannot fit all the use cases.
Right.
Which everyone is accessing, like these are the viral videos. So even with this, database structure and C, we still see some issue in the system. There's still some lag. Multiple people, someone accessing from India, someone accessing from, let's say, Australia. Everyone's trying to access this video, and we have some server. There's still a lag. What can we do about that? Yeah. So now the problem, let's say your database is everything in US. I am trying to accessing it from India. There will be a network latency. You can't avoid that. So that's why we use CDN. CDN is basically content delivery network. So these are kind of replicas of your data near to your region. So there will be one data center for Asia, one data center for US, one data center for Europe. So there are multiple data centers which has your videos replicated. And if I access it, there will be less network lag because I'm getting it from Asia. So this was about the high level, how you design a high level. Low level, how do you design low level? So you need API. Now we're talking about API side. So we need two APIs for our use case, one for uploading a video, one for viewing a video. Again, if you have to design this sort of application, what do you think multiple layers in your application should be like? You're just creating some APIs which will fetch the data and save the data. So here we are uploading the data and we are retrieving the video back. So how do you think the system should look like? Yeah, we will have some queues. Yeah, but this thing you have, so there are some thoughts in our mind, then we need to tell it to the interviewer. So it's always good to write something, discuss something. So this is how a typical web application or application server internally looks like. You have some sort of controller layer where you're saying all your APIs will go to this layer. From here, you will have a service layer which will add some business logic. So in our case, let's say they will do some, if you are, let's say, some sort of security check, it will decide what database and all to go to. And then there will be a DAO layer which will connect to the data. And since we want better performance, we will add some caching layer as well. So data access object layer. So basically, whenever we design a system, we try to keep it very low coupled. So basically, we are saying whatever is accessing database is just one layer. The whole purpose is to access the database. And there is another layer that not directly go to database. So that in future, if anything, let's say you change your table name, you don't want whole of your code to change. You just want DAO layer will handle that change, and they will provide another layer, let's say service layer. So that's a yeah, you can easily move. Though in reality, it's very rare that you move your database, but conceptually, if you move it, you just have to change this DAO layer. Your rest of the application will work as it is. No issues. So that's why we divide it into multiple. That's why even your control layer is different than service layer. Whatever changes is happening will happen in service layer, but your control layer will not be impacted by that. So that's how we design it. Now, this is like the high level diagram, but before you get into actual thing, you need to understand Hoops principle. So now we actually come to the class level. What all classes you should have in your controller layer? What all classes you will have in your service layer? How will your DAO access your database? So you need to understand your design principles, like solid design principles, design patterns, how to create a class diagram. Interview will ask you that, okay, what all classes you should have in your system from your class diagram. They can ask for a sequence diagram, that how a request is moving from, let's say, one layer to another layer, how is the complete flow. So then what kind of API you are using. So you're using REST APIs, you are using WebSockets. So all these things you need for a low-level design. And we have a separate section in our course for low-level design where we'll be covering all these aspects. Obviously, we cannot cover all the design patterns because covering all the design patterns which are mostly used in day-to-day applications. so that you have the clarity and you can apply them when an interview is asking about creating a low-level design. So we'll be covering all of that. Then another thing we can do with our system is, so right now we have one app server which is doing everything. It is helping you upload videos, it is helping you view videos, it is helping you, let's say you want to add comment, same server, same functionality is replicated across servers. Instead, nowadays, people have started using that you create a particular service, and let's say you have one service just to watch videos. So it's kind of just a read kind of application. You just read. One separate server just to upload the videos, kind of just a write. One for, let's say, storing comments, liking, all the metadata kind of related to videos. So what is the benefit you think of having these multiple services instead of having everything, jumbled up into one server?
Basically, so you are giving more people, that server. So we'll get more requests per week. So in that case, the only view service, so we can not apply multiple instances. So the create, so we can apply in a single.
Yep. Any other advantage?
Management would be easy.
Yeah. You have smaller services, it's easier to manage. Other thing will be, let's say you have to release a new code, which just impacts, let's say, how you add comment. Rest of services need not be impacted. You can leave other services as it is. There is a minor downtime, even if you have a downtime in the comment section, not otherwise. If your one server crashes, your other services are still working. So let's say upload service crashed because of some reason. So upload is not working, but at least people are still able to view the videos. You can make your system more scalable if you have more services. So let's say now I know that view is very read heavy. So instead of using same resources for, let's say, view and upload, I'll have a separate server for upload, let's say less resources, and I'll put all my resources in the view because I know that's the service easy to handle small services, downtime. So these are basically called microservices. And again, we will be covering it in our course that how microservices, different microservices interact and what's the benefit of using microservices versus a monolithic architecture where you jumble up everything in one go. So we'll be covering it in more detail. Now we see some other sort of issues as well. First time. You also try to create it with, let's say, name XYZ. I also try to create the name XYZ exactly at the same time. What?
So basically, before we are storing the data, right? So we have to check the database that record is there or not with that name.
So let's say you went to database, record was not there. I went to database, record was not there. We are doing it simultaneously. The database responded to you, yes, you can create it. Responded to me, yes, you can create it. We both went and created the same user. What else can we do?
Database side we can describe. So like when we whatever the user will that will be.
Yeah. So basically, some sort of constraint, unique check in place. Before database can be restricted. Yes, we can do synchronization. We add kind of a log in our application. In one server, but what if you have multiple servers? How will you manage logs across servers? So there is a possibility that user 1 went with name XYZ server 1, other user went to server 2 with same name XYZ. But obviously synchronization will create more problems when you have multiple servers. So how to handle that? One way is you can use optimistic locking. So we have a concept of passive locking and optimistic locking. So optimistic locking means so these are used mostly for update. If you're updating something, your name XYZ, so we'll set okay, set name is equal to XYZ where XYZ doesn't exist. So if your query was successful, my query will fail because now XYZ exists in database because you already updated that. So how to handle these conditions in a distributed environment, optimistic blocking, how to handle synchronization. So for a banking application, I cannot use this technique. That okay, debit his account as well, debit his account as well. We'll see later that if it's successful or not. So we can't do that in a banking transaction. So there we have to use pessimist blocking. But in a distributed system, how to handle it, we'll cover it again in more detail in our course. So these are the when you are in interview. Sorry, any question?
Hello. Yeah. So
Yeah.
actually, I was just curious because so these kind of a conditions when we are saying that okay, two users trying to create the account at the same time.
Yeah.
So this I think we can handle simply that okay, if we are taking some unique ID now, so how it will with the help of that we can do now.
Sorry, unique ID in the sense?
So suppose my email ID is user1 at the rate gmail.com. Some other user will be the user2 at the rate gmail.com, right? So we can create we can handle
Yeah.
that situation in that way, no?
Yeah. So this is where already assuming that user has already have the email. So let's say when you were creating your email for the first time, you were selecting your username for the email,
Right.
right? So let's say when you were creating your username with let's say XYZ, I was also creating the Gmail account with the same name XYZ. Now what will you have? I don't have any account with Gmail as of now. You don't have any account with Gmail as of now. First time you are registering. I'm also trying to register with the same name. Given there are
So
like thousands and lakhs of people. Yeah.
okay. So when that request will come, that will be handled at the DB level. Now, why application should be responsible for this?
That's what I'm saying. So let's say I handle it at DB level.
And also, as a developer, we are not
The
responsible. Now,
GPI exactly.
yeah. Sorry.
Sorry, as a developer, if you are designing a system, you are responsible for these sorts of edge cases. Who else will be responsible?
Because the see these kind I mean I'm sorry I'm just little bit more because I have seen these up kind question and why
Yeah.
race condition because the people who are really designing at the very low level they people are going to handle the race condition and optimistic locking. Suppose if I'm creating the database at the low level, I'm writing a database at itself, then I need
Yeah.
to take these conditions, but as a developer how, where it will come.
No. So yeah. So we are not saying you are a database developer. We are simply saying you are creating an application. There is a
Okay.
possibility that two users can access the application at the same time, and they can do a similar operation. So let's take an example. You have seen wiki page. We have
Okay.
wiki. So let's say you go and try to edit the wiki. I also try to edit the same wiki. We are both trying to do it at the same time.
Okay.
Editing something and also someone else is, there should not be a mix up. There should not be a lost update, right? Either you tell me like Microsoft use a pessimist approach. If you open an Excel, a shared Excel, someone else tries to open it, it will simply say someone is modifying it. You can just access it read-only mode. Either you go by this way, which is pessimist, but you have to do that. Second is if you're designing, you say that okay, users are doing the same thing. Once you are storing it, you will have some sort of check in place so that update is not lost. Otherwise, no one anyways, we'll cover these sort of scenarios in detail in the course because obviously it will take much longer time to go through each and every scenario and find a solution. So this is today's demo. Anything you guys have? See the chats as well. Yeah. Any questions? Anything? Nope. Sorry. So you see, we kind of have 5 sections. The high-level architecture diagram, taking real use cases, different scope, these sort of systems, and then we'll have multiple assignments on that. Then we'll be covering low-level design. Principles you should be aware of, design principles, design patterns, how REST APIs work, and we'll have hands-on on some REST APIs. how to handle synchronizations, race condition, and distributed system, and then we'll cover microservices as well. Like, because it's kind of a buzzword. You go in an interview. So basically, since we are focusing on, if you're going to interview, and these are, covers everything. In the end, we'll also have a mock interview. So we'll be taking your interview and we'll give you a feedback on real-time basis that, okay, this is what you could have done better, or this was the better way to handle it. So to give you that sort of experience that, really give you confidence that next time when you go to a system design interview, you are much more confident and you can handle it. Any other question? It's starting September 29th, Saturday, last week of September. So in system design interview, you don't need exactly DS and algo, because obviously we are not going to discuss here that what algorithm you should use, what data set you should use. That is something part of a separate course where we cover all the DS and algo. This is high level. You are designing a system, because design is a different beast altogether. That you need to understand what sort of challenges you will have in a design when you have multiple servers, distributed systems. So there you don't need knowledge of exactly algorithms and DS. If you go really deep into that, okay, I have high level design, I have low level design. Now someone asks you that, okay, what algorithm you will use. So that's not a design question. That's more of a coding or programming sort of question. So you don't need DS algo exactly for coming here. If you have basic understanding of OOPS and some work experience with any programming language, any object-oriented programming, I'll say there is no issues. We'll cover everything from scratch. Okay. Thanks, guys.